Hello again, pre-calculus classes. We are going to look at lesson 5.3 today and learn a new set of identities. These are our sum or difference identities, and these identities are helpful in being able to find a sum or a difference, but a sum or a difference when they are non-calculator problems and they're not numbers we know off of our reference chart or off of the unit circle. So right here we have the sign of a sum or difference. And as you notice, the sign of sum or difference, its sign of x plus or minus y is equal to sine x cosine y plus or minus cosine x sine y. And so it's basically kind of a fill in the blank. You put the x's and y's where appropriate. In this particular identity, if you have a plus in the original problem, you'll have a plus in what it equals. If there's a minus in the original problem, minus in what it equals. As you look down at the next rule, the cosine of a sum or a difference, you'll notice it's cosine of x plus or minus y equals cosine x cosine y. And notice this time it's minus plus sine x sine y. So this time, if you have a plus in the first statement, you'll have a minus in the other statement. And vice versa. If you have a minus, then it equivalates to a plus. And we'll look at some examples there. And then we also have the tangent of a sum or difference. Notice tangent of x plus or minus y is equal to tangent of x plus or minus y, so keeping the sign the same, all over 1, notice this time it's minus or plus, tangent x, tangent y. Okay, we're going to look at example 1, and you'll see several examples like example 1 in your homework when you get to your homework, which, like yesterday, what I'm doing with the homework is today, which is Friday officially, when you'll be watching this, your e-learning is just to go through these notes, copy the notes down, work to understand them. Your e-learning for Monday will be to do the homework. Now, you are welcome to work ahead and go ahead and get that e-learning done while it's fresh in your brain if you want. That is fine. You can even submit it ahead. Once I post these, I will also open Monday's e-learning that shows you the assignment. But I'm kind of taking 2 days a lesson here. Okay, so as we look at example 1, it says find notice the phrase, exact value of cosine of 15 degrees without using a calculator. That means if you try and cheat and you try and do cosine of 15 degrees on your calculator, you'll get me an answer, but it'll be an approximate answer because it'll be a decimal you'll have to round. The answers we're going to have when they're exact involve fractions, square roots usually. So what we need to think about is a sum or a difference that equals 15 that uses two of the numbers from our reference chart. And if you think about the numbers on our reference chart, there's 3 main numbers we have on our reference chart, and those are 30 degrees, 45 degrees, and 60 degrees. So can you use those 3 numbers to come up with 15 degrees? And hopefully you'll notice that's very easily possible. There's actually 2 different ways, or at least 2 off the top of my head, that we could subtract numbers to get 15 degrees. I was going to go with 45 minus 30 is 15. However, if you want to be more challenging and try your own, you could also do 60 minus 45. They'll both end up at the same answer in the end. It'll just look different in the middle steps. So the first thing I'm going to do is I'm going to take this cosine of 15 degrees and I'm going to rewrite it as cosine, and I'm going to use 45 degrees minus 30 degrees. As I said, you could just as easily use 60 minus 45. Okay, so now we're going to apply our theorem from our identity from above. It says cosine of x plus or minus y. So first of all, the first part you notice is cosine x, cosine y. Well, have you figured out what our x and y are? Our x value that we're going to be using here is basically this 45. Any place you see an x, you're going to put a 45. Our y value is the 30 because that's what matches up with cosine of x plus or minus y. So every place I see x, I'm putting 45. Every place I see 30, I'm putting y. Y, I'm putting 30. Okay, so it says cosine x, cosine y. So that means I'm going to write cosine 45 degrees times cosine of 30 degrees. Now, notice this one. This identity says plus or minus in the initial is minus or plus in the other side. That means since we were given a minus this time, we're actually going to use a plus. And then it says sine x sine y. So we're going to say sine of 45 degrees times sine of 30 degrees. And that is your first step in writing out the sum or difference identity for cosine. This is the type work I would expect to see on your paper as you're working through it. Okay, please don't skip this step. Our next step is I'm hopeful you have your unit circles reference charts by your sides as we go through this, but these are all things we know. Let's write them down. Cosine of 45 degrees from your chart is square root of 2 over 2 times cosine of 30 degrees. Also on your chart, that is square root of 3 over 2 plus sine of 45 degrees, according to my chart, square root of 2 over 2 times sine of 30, according to my chart, is 1/2. Okay, guys, you've done all the hard work. At this point, it's cleanup stuff. So remember, our dear Aunt Sally, or PEMDAS, says we need to multiply before we add. So square root of 2 times square root of 3 over 2 times 2 is going to be square root of 6 over 4 plus square root of 2 times 1 is square root of 2 over 2 times 2, which is 4. Generally, you will see it going one more step and adding those together. Notice there's already a common denominator, so that common denominator is 4, and then my numerator is just going to be square root of 6 plus square root of 2 equals 4. And there you go. That is using the cosine identity for a sum or a difference. Now, if you wanted a check, you could put square root of 6 plus square root of 2 all divided by 4 into your calculator and get a decimal. You could also do cosine of 15 degrees, make sure your calculator is in degree mode, and get a decimal, and those decimals should match. So if you want to just kind of check and make sure you're understanding, that would be helpful. Okay, that is the way we most typically use these sum or difference identities. And that is what I think you'll be doing on 1 through 10. Now, when you get there, you'll notice the first handful are in degrees. The next handful are in radians. So, before I continue, one thing that I just want to mention is think about radians. We already know 30, 45, and 60. 30 degrees is equal to pi over 6. 45 degrees is equal to pi over 4. And 60 degrees is equal to pi over 3. You will notice that a lot of your problems involve twelfths. And not quite all of them, but a lot of them can be done by just thinking about these in terms of twelfths. So if I make all of these with twelfths, pi over 6 becomes 2 pi over 12, because 1/6 is 2 twelfths. Pi over 4, well, 1/4 is 3 twelfths, so that's 3 pi over 12. And pi over 3, well, 1/3 is 4 twelfths, and so that would be 4 pi over 12. So I just want you to have those available to you, just as something to think about that will be helpful as you go through 1 through 10. If you can't get two of these to add or subtract to be what you need, my hint will be you might have to go into another quadrant, like maybe use something from quadrant 2 to make it work. So give those a try, see what you can do with them. I want to move on to example 2 now. And example 2 asks us to write each of the following expressions as the sine or cosine of an angle. So we're basically going to take what we just had and reverse it. Okay? They are giving us the expanded form. We want to write it so that it is, for instance, like cosine of 15 degrees earlier. So first of all, I would work to look at A. It's sine 22 degrees, cosine of 13 degrees, plus cosine of 22 degrees, sine of 13 degrees. Ask yourself, does that look like a sine, cosine, or tangent identity from the form above? And I will hope you'll notice, since it's sine, cosine, plus cosine, sine, that that is of the form of a sine identity. So I know this is going to be doing the sine of something. The next thing I need to identify are my x and y. So if you look up above, again, look at the format. It's sine x, cosine y. And then it's plus or minus cosine x, sine y. And that right there will tell you your x and y values. And so notice, this is the sine cosine plus cosine sine. It's equal to sine of x plus or minus y. So my x is going to be 22 degrees. My y is going to be 13 degrees. And then my question becomes, do I put a plus sign or a minus sign in between there? You'll notice we were given a plus sign. And what does the sign identity say? It says to keep the same plus or minus sign. So if it was plus sign here, we're going to have plus sign there. And so sine of 22 degrees plus 13 degrees, do the basic addition there. And this will become the sine of 35 degrees. My directions ask me to write each of the following expressions as the sine or cosine of an angle. And I just did that. So sine of 35 degrees is what I'm looking for. I think after all the solving and proving and simplifying we've done lately, I hope you're finding this lesson a little bit easier than some of these others we've done. I'm hoping. Okay, let's look at B. Cosine of pi over 3, cosine of pi over 4, plus sine pi over 3, sine pi over 4. Okay, is it a sine, cosine, or tangent identity? I'm hopeful you can say cosine right there, since it's of the cosine, cosine, plus sine, sine form. Can you identify your x and y? If it's cosine x, cosine y, my x is pi over 3, my y is pi over 4. And then it's supposed to be sine x, sine y. So my x is pi over 3 again, my y is pi over 4. So notice that works. So we're going to have the cosine of pi over 3 and pi over 4. And then the question becomes, is this a plus or a minus? Notice we're using a cosine identity. The cosine identity was a plus. And so we're going to put in a minus here by changing that sign. So we have the cosine of pi over 3 minus pi over 4. If you would, please simplify that. So I'm going to need a common denominator of 12ths. And so this is going to be 4 pi over 12 minus 3 pi over 12. And that's going to simplify down to be cosine of pi over 12. Okay. Start looking at the next one. And as you start looking at the next one, what do you notice? You need to start by being able to identify which one it is. And as you start to notice there's sine, sine, cosine, cosine, which most closely resembles the cosine form, but in a backwards order. So my recommendation here is that we start by flipping it around. And when I flip that around and write it of the form cosine x, cosine 2x, and then sine x, sine 2x, we need to think about our plus or minus signs there. And right now, it's a minus cosine and a plus sign. But you'll also notice when we look up at the form up there, cosine always starts as a positive. So my recommendation is that we're going to factor out a negative, which will change the signs. So if I factor out a negative here for my cosine, the negative's out front. My sine was originally a plus, but if I factor out a negative, so divide by a negative, it is now a negative. And so how we're going to do this is we're going to put the negative out front of whatever we do. So there's my negative out front. We decided this was a cosine identity, so I'm going to say cosine. I need my x and y values, so to speak. My x value is going to be an x. My y value is going to be a 2x. So this is x and 2x. Look at my parentheses here. I have cosine minus sine. And the cosine says to flip the sign. So this is going to be a plus. Clean it up. And I have the negative cosine of 3x. Yes, you can leave that negative out front because it's just identifying it would be the opposite of whatever cosine of 3x is. So that was a little twist in there. Again, you manipulate it to make it work. And lastly, D. Do I dare say it? D is obviously the tangent identity. It has tangent in it. It's of the tangent form. Tangent 22 degrees plus tangent 23 degrees over 1 minus tangent 22 degrees, tangent 23 degrees. We need to identify our x and y. So for my x, I'm going to use 22. For my y, I'm going to use 23. So this is 22 degrees and 23 degrees. And then check your signs. Do I want 22 plus 23 or 22 minus 23? Notice tangent will match up with your top sign and be opposite your bottom sign. And so that means I'm going to want a plus. Clean this up, and this simplifies to be the tangent of 45 degrees. Okay. Last section. We're going to talk about example 3 now. Notice we are going back more to what we did on the first part. We're going to use our identities again. This says the sine of x plus pi. So let's use our sine identity. Again, whether you physically write it down is up to you, but mentally identify what your x and y are. In this case, my x is x, and my y is going to be pi. So let's write out our sine identity. Sine identity reads sine x cosine y. So sine x cosine of pi. My sine identity says to keep the same sign, so it's going to be plus. And now we flip-flop. It's cosine x sine y. So cosine x sine of pi. Now we need to do some cleanup here because as you'll notice, x is x. There's no changing that. However, pi is a number on our unit circle. That's over by the 180 degrees. And we have answers. We have values for those. So grab your unit circles and check it out. Sine x is going to stay sine x. Cosine of pi. So if I go over there, cosine of pi, so remember in ordered pairs, cosine sine, so the x value, when I'm over there, I went left 1 and up or down 0, so it's negative 1, 0, so cosine of pi is negative 1. Plus, cosine x stays cosine x times sine of pi. So again, that ordered pair to the left is negative 1, 0. The sine value is 0. And last cleanup. Cosine times 0 is 0 and gone. Sine x times negative 1 is going to be negative of sine x. And so notice, by putting a number like pi in there, we are able to simplify it quite a bit. And you'll notice that as we talk about these, we are working with quadrantal angles here. Okay, 2 more. We're almost there. Cosine of x plus 3 pi over 2. Again, know what your x is and know what your y is and know that identity. So the cosine identity starts cosine x, cosine y. So mine's going to be cosine of x times cosine of 3 pi over 2. Cosine identity says to change the sign. So since they gave me plus, I'm using minus. And now it's sine x, sine y. So sine of x times sine of 3 pi over 2. Clean it up like we did last time. Cosine x is still cosine x. Cosine of 3 pi over 2. So that's when we're going down on the y-axis there at 270. Left or right, 0, down 1. So that would be the ordered pair 0, negative 1. So the cosine is going to be, cosine of 3 pi over 2 is going to be 0, minus, it's still sine x. The sine of 3 pi over 2, when we go down 1, is going to be negative 1. So clean this up. Cosine times 0 is gone, it's 0. Negative sine x times negative 1 is going to be positive sine x. Okay, last one. We get to practice with a tangent here. Tangent of theta minus pi over 4. Remember, theta is another variable just like an x or a y. So I'm going to identify my x and y here and work through this one. This one's not a quadrantal angle, but that's all right. We're still going to do the same technique. So tangent of theta minus pi over 4. Tangent says, first of all, I'm going to set up a fraction. On top, it's tangent x plus or minus tangent y. So mine is going to be tangent of theta plus or minus tangent of pi over 4. Plus or minus, which is it, guys? Notice, plus or minus stays plus or minus. So since this one was minus, it's going to be minus. The bottom is 1 minus plus, so that means I'm going to change my sign. It's going to be plus tangent x, tangent y. So tangent theta, tangent pi over 4. Okay, pieces with variables stay variables. Anything that has angles, you simplify. So tangent of theta stays tangent of theta. Minus, okay, check those charts out. What is the tangent of pi over 4? Tangent of pi over 4 is 1. Over my denominator, 1 is 1, plus tangent of theta stays tangent of theta, times tangent of pi over 4 again is 1. Okay, not a lot of cleanup we could do here, but that's all right. My numerator is going to stay tangent of theta minus 1. My denominator, it's 1 plus tangent theta times 1. Well, tangent theta times 1 is just tangent theta. So you can either say 1 plus tangent theta, or what I have written down is tangent theta plus 1. And that is your final answer there. Okay, you will notice I have written at the bottom, the homework is page 425, 1 through 22. That is not officially assigned today for Friday e-learning. That will be your Monday e-learning assignment to complete the assignment and submit it back to me. Schoology, email, someplace, submit it back to me. Okay? Take a picture using your computer, cell phone, whatever it is, and get it submitted. I may possibly be starting to check in with some of you that I'm not seeing anything being submitted. We have been asked to follow up and making sure everyone's getting the e-learning and all of that. So please communicate with me if there are issues, problems, anything I can help with. And I will be more than happy to do what I can. It looks like things are going to be extended. I'm recording this Thursday afternoon, and they've just announced that no one in the state of Indiana will go back to school before May 1st. So we've got a while longer of this to go. So again, please communicate with me if there's anything I can do to help or any issues we need to resolve. So hope all goes well, and I hope you enjoyed this lesson a little bit better, and it was a little bit of a break from some of the more difficult lessons. Good luck, and I will talk to you guys soon. Bye.